Hello everyone, welcome to Learn AI. Today we'll basically continue with the machine learning series. In the previous session, we had an introductory session to machine learning where we also discussed actually what is machine learning, different types of machine learning, how does it differ with respect to your normal standard program. So today we'll basically continue from there. So we'll basically look at different machine learning algorithms. Okay. I think as discussed in the previous session, we'll basically look at very few a few standard algorithms. We'll basically try to understand internally how it works, right? So basically, how the machine learns, right? So we'll basically try to understand how the basic machine learning process happens. And before that, machine learning algorithms are generally divided into one. You have your linear algorithms. The other one is your non-linear algorithms. Okay. So basically, how do you know it's linear? How do you know it's non-linear? Is basically how do they capture the pattern? Right? So consider the case of your normal linear regression. So in linear regression, your basic equation, right? Your basic equation is nothing but a straight line. Right? But in cases of certain other algorithms, like it could be decision trees or boosting algorithms, so its equation is not a simple straight line, right? So you have your complex tree structures. So basically, if the decision boundary is sort of a linear, you call it generally linear algorithms. If it comes under non-linear, you call it as non-linear algorithms. Right? It's like a very simple, straightforward explanation. So today, yeah. So continue. So moving on. Today we'll basically look at linear regression. Okay. So what is basically a linear regression, and we'll basically try to understand how linear regression works. Before that, there are a few technical terms, I think, the meaning of which needs to be understood. So let's say, the technical terms for which meaning to be understood is something called as hypothesis function. Then there's something which is called as a cost function, cost or loss function, they mean the same. Other one is something which is called as an objective function. Right. So we'll start off with hypothesis function. So what basically is an hypothesis function is it's nothing but how your features are related. So how your x variables are. So basically, how do you combine x variables to basically predict the output? In terms of, say, if you consider actually a linear regression, right? Considering the example as a linear regression. So the hypothesis function for linear regression, say the general equation, right? General equation for linear regression is nothing but say, okay. So y is equal to mx plus c is the general equation for linear regression, right? Now, say when you actually convert this into your normal standard format, obviously this is also standard format, but the easier way of writing this is say we write beta naught plus beta 1 x1 beta 1 x1, then you have plus beta 2, right? So you have beta 1 x1 beta 2 x2, right? So this is again a more cleaner way of writing this. So what basically your beta 1 beta none beta naught beta 1 beta 2, nothing but your weights. So these are the value of your weights. Now this is what the hypothesis function is. So the hypothesis function basically describes how the x variables are combined, or basically how the equation is represented, right? So it's nothing but your what is your standard equation format, right? And again, you cannot use this hypothesis function, say, in a logistic or in any other algorithm, because this is, say, hypothesis function, I think, is applicable only to certain algorithms. Linear regression is one. So next we'll basically look at hypothesis function is one. Next we'll basically look at what is a loss function. Loss function basically is one. It's basically defined on a data point. So what basically loss function measures is basically what is the error in your model's prediction, right? So loss function or cost function. So it's basically used as a measure to understand what basically is the model's performance, and so how well it is performing in comparison to your actual output. Generally, what you generally do is you just basically compare it with the actual output. Say you have a certain value as the actual output, then you basically compare your predicted output, your model's predicted output with that of the actual, and basically understand what's the difference. So you need a metric to measure that. Cost function is basically that. So coming to objective function, right? So objective function, it's actually a very general term. So what objective function basically is, it will tell you what you're trying to optimize. So whatever objective function is, whatever function is there, right? So objective function is one which is basically optimized to find out the weight values. So I think maybe this might not be so clear, but maybe I think when I explain this with an example, things should be more straightforward. But this thing is cost function. It basically measures how well your model is performing. Your objective function is one which is basically optimized. Okay. Again, it's a very general term. The hypothesis function is basically your equation, your algorithmic equation, right? Which is sort of basic building block.